Yeah, write this down. Sometimes you need to use your identities in solving equations. So the question we just did before was a proving question. Now we're going to do some solving questions where we have to use our trig identities. So our strategies. Can we write our equations using only one trig function? So sometimes we've had questions that have had a sine squared and a cos. Well, then you can use sine squared plus cos squared equals 1 to write it only in sine or cos. Sometimes you can use your double angle formulas to change things to only be in one trig function. So that's going to be one of our strategies. Whenever possible, we're going to see, can we write this equation with only one trig function? Sometimes you can't. Some equations, like that question from section 7.2 in the homework, number 12 that I mentioned in the last class, some questions you can't write it as a single trig function, and in that case you're going to need to factor. Can you factor out a common factor? And when both of those things don't work, another strategy is changing things to sine and cos and getting rid of any fractions that are there and see what you come up with. I'm going to scroll this down just that far so you can see what your first question is going to be. So in this first equation, we're solving for theta between 0 and 2 pi of cotangent equals 2 cos theta. So one of the things that we're going to look for, is there a way to change cotangent just to cos? Or is there a way of changing cos just to cotangent? Because if you can change it to one function, that would be the first thing you would try. But unfortunately, in this case, there's not a way to change cotangent to just cos. There's not a way to change cos to just cotangent. So we're not able to write it with only one trig function. So then we look at what else could we do. Is there anything we can factor on either side? No. So we might have to go to the third thing. Let's change things to sine and cos, and then eliminate any fractions. So if I change cotangent to cos theta over sine theta, what I can do to eliminate the fraction is right now I'm dividing by sine theta. The opposite of dividing by sine theta is I can multiply both sides by sine theta. That will get rid of the fraction on the left side. And I will get cos theta equals 2 cos theta sine theta. And what you do next, right now, because I'm going to ask you just to think, what should you do next, will determine what you would do next on the test. And people do one of two things. Both ways get some right answers. One way will not get all of the right answers. So I want you to think, what would you do next as your next step? So we've multiplied, got rid of the fractions. Now we only have sine and cos. Think to yourself, what would you do next? So here are the most common things that students do next. One, people make one side equal to 0. The other is divide everything by cos so that you only have one trig function. Now, if you went from here, this side has only sine, so if we get sine by itself, sine theta equals 1/2. That's on your pi plate, and you would get the following answers. You would get pi over 6 and 5 pi over 6 as your answers. If you did what's on the left side, you still have two different trig functions. But in our strategies, if we can't change them because none of them are squared, so we can't use this, because you can only use the sine squared plus cos squared equals 1 to substitute if one of them is squared. But we can factor out a common factor. What's the common factor in both of those terms? It's cos theta. If you factor out the cos theta, you're left with 2 sine theta minus 1. And this is where it's multiplying, so either cos theta is 0 or sine theta is 1/2. When is cos theta equal to 0? So where were we? We were on the left-hand side. If cos theta is equal to 0, then theta would equal, when is your x coordinate equal to 0? At 0. It's not at 0. X coordinate is equal to 0 at pi over 2 and 3 pi over 2. Okay? And sine theta equals 1/2 is, well, pi over 6 and then 5 pi over 6. So let's compare these two. Both of them got pi over 6 and 5 pi over 6, but only the left side gives us these additional answers that work, pi over 2 and 3 pi over 2. So if you divide by cos, you run into a problem. And on this side, you're going to lose a mark for dividing by cos. It's tempting because you get to a single fraction and you get some answers that are right, but you're going to miss out on some other answers because it's possible. Can you see right now, just looking at the blue equation, that if cos is equal to 0, 0 would equal 0 and it would work. So the problem with this method right here is that when you divide by cos, you might be dividing by 0. And dividing by 0 is bad. Right? I've got a picture up here on the wall. You can look at it later about someone who tried to divide by 0 in their own home and the disaster that occurred. So whenever possible, it'll always be better if you're thinking divide as a strategy, you can move that over to the other side and factor instead, because you might be dividing by 0. So anytime you're dividing by a function of some sort, you have to be careful because you might be dividing by 0. All right, the next thing I'm going to show you is questions where you might use the double angle formulas. Okay? So you have room on page 667. If you see a 2 theta in a question, you might think that this is a multi-revolution question, but it might be one where you should use a double angle identity. So I'm going to show you 2 different cases, one where it's a multi-revolution question and one where it's a double angle identity, and how you can decide which of the 2 you should use. So I would suggest you only have the trig function with the double angle. So in your equation, the only thing you have is the trig function with that double angle. Solve it as a multi-revolution question. But if you have a double angle and another trig function in that, then we're going to solve it using one of our double angle identities. So for the one on the left, since we just have a cos 2x and we don't have any other trig functions, if we were solving this like a double angle identity, we would get the cos by itself. Since 1x is between 0 and 2 pi, 2x's will be between 0 and 4 pi. Oh, this will be positive, right? Moving it over to the other side. Is root 3 over 2 on our pi plate? Yes. What family? No. Pi over 6 family, and it's going to be positive, so it's quadrant 1 and quadrant 4. That's only the first time around, though. For 2x, we have to go to 4 pi. So the second time around, we'll have 13 pi over 6 and 23 pi over 6. How did I do that quickly? With my first one, I'd have to add 2 pi to get there. But since it's over 6, to get a common denominator, 2 pi is the same as 12 pi over 6. And same thing with this one. If I added 2 pi or 12 pi over 6 to that one, I would get 23 pi over 6. So that's what 2x is equal to. Then if I want to figure out what x is equal to, I have to divide by 2. And I'd get the following 4 answers. And all 4 of my answers are between 0 and 2 pi. The example on the right-hand side has a double angle, but it has another trig function in the equation. So when you have this situation with a double angle and another trig function, you won't treat it as a multi-revolution. You'll go to your identities, and you'll substitute in. Again, we're in that same situation where you have 2 possibilities here. You might be tempted to divide by sine x, but instead make one side equal to 0 and factor. So there's a common factor of sine, leaving you with 2 cos x minus 1. Which means sine x could equal 0, cos x could be a half. When is sine x equal to 0? At 0 pi and 2 pi. When is cos x equal to a half? Quadrant 1 and quadrant 4 is where it's positive. Pi over 3 family. Again, whenever I finish my answers, I do a quick check back to my domain to make sure that I solved over the right domain. And this one was between 0 and 2 pi. And 0 and 2 pi were included. That's something I'm looking for because those were in my answers. So sometimes in your textbook they'll include 0, but they won't include 2 pi or something like that. So we always have to be careful to look back at our domain. So here are some examples of, now that we've learned some more stuff, the questions get more complicated because when you see a double angle, at one time you were thinking, oh, maybe this is a multi-revolution type of question, but now you have to use both. Maybe this is a double angle type of a question. So being able to recognize both of those strategies and when they both work.